One, A, in a loop-the-loop toy, a car of mass 0.12 kilograms is released from rest. The initial position of the car is 45 centimeters above level ground. The radius of the circular loop is 15 centimeters. The car reaches the top of the loop at position P. Frictional and air resistance forces are negligible. This position P. Show that the speed of the car at P, the speed on this position P is 1.7 meter per second. I would like to start with this equation that on this position, the potential energy equal the kinetic energy, right? So potential energy is the product of mgh, and kinetic energy is 1/2 mv squared. If m divided by m equal 1, so we can writing that v squared equal 2 times g times h, or phi equals square root of 2gh. Now we calculate phi or speed, 2 times 9.8 because this is gravitational force, and h is 0.15, right? So because 15 centimeters is 0.15 meters. So if you calculate, the result is 1.72 meter per second, or it is 1.7 meter per second. Next question. Determine the normal force exerted by the loop on the car at P. So using Newton's second law in the vertical direction, Fn plus mg equal mv squared divided by r. So we can rearrange that Fn equal mv squared divided by r minus mg. And after that, substitute the information, the number 0.12 times 1.72 squared divided by 0.15, r/0.15, and it is mass is 0.12 times gravitational force 9.8. And if you calculate, the result is 1.2 newtons. State why the car stays in contact with the loop. I provided my answer for this one. Okay. As long as the normal force is greater, it means is this positive greater than zero. Okay, if n greater than zero. So you can copy this, or maybe you can add in something, or you have the different opinion, up to you. Next, B. At point A, the car collides with a block of mass 0.18 kilograms and sticks it to it. After the collision, the car and the block move together with speed 1.2 meter per second. Okay. Calculate the speed of the car just before it collides with the block, right? So from number one part A, we got the velocity. The velocity equals square root 2gh. Substitute the numbers is 2 times 9.8 times the H is 0.45. Okay. So it is 3.0 meter per second. This is the speed. And the surface from A to B is rough. And the combined car and block come to rest at B. The distance AB is 0.20 meters. Determine the rate of change of momentum of the combined car and block from A to B. Right. Uh, I will using this formula, F times D equal 1/2 M1 plus M2 times U squared. And it's going to be, I will rearrange, this formula becomes F equal D times 2, so it's going to be M1 plus M2 times U squared divided by 2D. So F equals 0.12 plus 0.18 times 1.2 squared divided by 2 times 0.20. And if calculate, the result is 1.08 newtons or 1.1 newton. So this is rate of change of momentum or impulse. We can say that this is impulse. Next. Calculate the dynamic coefficients of friction between the rough surface and the combined car and block. We can use the force of friction and Newton's second law, that F equal mu times M1 plus M2 times G. Or you can rearrange this formula because mu becomes the subject. If mu is the subject, this formula becomes F divided by M1 plus M2 times G. G is gravitational force. So mu equal 1.08 divided 0.12 plus 0.18 times 9.8. And the result is 0.367 or 0.37. That's the dynamic coefficient. Number two, outline by reference to Newton's third law how a gas in a container exerts pressure on the container wall. I have provided my explanations. One. Next question, B. State one difference between an ideal gas and a real gas. Also provided. One. And C. Two containers of volume 0.20 meter cube and 0.10 meter cube are filled with an ideal gas. The pressure in the larger container is 3.0 times 10 power 4 Pascal. The pressure in the smaller container is 9 times 10 power 4 Pascal. The temperature of the gas in both containers is the same. A thin tube with a valve joins the containers. The valve is initially closed. So condition. The valve is open so that gas can move from one container to the other container. The temperature remains unchanged, determining the new pressure of the gas. I'd like to use this formula that P1 plus P2 V2 equal P times V1 plus V2. So P1 3.0 times 10 power 4 times 0.20, okay, plus 9.0 times 10 power 4 times 0.10 equal P. Phi1 is 0.20 plus 0.10. So 3 times 0.2 is 0.6 times 10 power 4. That's one. 0.9 times 10 power 4. 3 times 0.30. So 0.9 plus 0.6 plus 0.9, 1.5 times 10 power 4 equal P 0.30. So we can determine P as 1.5 over 0.30, okay, times 10 power 4, or this is 5.0 times 10 power 4 to the power 4 Pascal. Number 3, state what is meant by a transverse wave. I have provided my answer. One, a transverse wave is referring to the line on a string. The graph shows at one particular time the variations of displacement y with distance x along the string. The points P and Q on the string have been marked. Explain whether P or Q has the greater accelerations. I have provided my answer about this. The speed of the wave is 62 meters per second. Calculate the period of the wave, giving your answer to the correct number of significant figures. Right. Right. So it's one. So I would like to using this formula that T equal lambda over C. Lambda is 1.2. If you look at this graph, this diagram is 1.2 from this point to this point. It is lambda. Okay, this one. 1.2. That's why lambda equal 1.2, 1.20, and divided by 62 according to this information. Okay. Meters, and this is 1 meter per second. So the result is 1.936 times 10 power minus 2, or 1.9 times 10 power minus 2 seconds. Calculate the average speed of P during one complete oscillation. Right. So the formula I would like to use for speed is velocity for D over time taken. D distance is 4 meters. Sorry, 4 centimeters according to the graph. Right? 4 centimeters. 4 centimeters, if you convert to meters, it's going to be 0.04 meters. Because 4 divided by 100. So it becomes 4 times 0.04 meters by this is T 1.936 times 10 power minus 2. That one 8.3 meters per second. The string is now stretched between an oscillator and a fixed point. When the oscillator is set to a frequency of 120 Hz, the standing wave shown in the diagram is observed on the string. Draw the standing wave that will be observed on the same string when the oscillator is set to a frequency of 180 Hz. So from this point to this point is 120 Hz. So it means this point is 60 Hz. So the frequency. So if 180, it means there are three 60 Hz. So I will divide becomes three parts. Okay. From this point to this point is 60, 60, and 60. Complete 180. Okay. Next. Physicists and engineers study simple harmonic oscillations, even though most oscillations are not simple harmonic. Suggest why this is a useful thing to do. I have provided my explanation about this, my answer. Okay. As HM is simple harmonic motion. Number four, two resistors X and Y are connected in series to a cell of EMF E and negligible internal resistance. The resistances of X and Y are constant. The power dissipated X is greater than that in Y. State and explain how the resistance of X compares with the resistance of Y. I have provided my answer about this one. Next, X and Y are now connected in parallel to the same cell, just now in series and this one in parallel. State and explain which resistor has the greater power dissipation. This is my explanation. A LAMZ and a resistor R have the IV characteristics shown in the graph. Calculate the resistance of R. I would like to calculate the resistance of R on this point. I'll take this point, this current point is 8, 50, 50 milliamps, but 50 milliamps is equals 0.050 amps, right? And so this is 8 feet and this is 0.05 amps, right? Let's recalculate. Recalculate that at point 8, 50 R equal V over I, V divided by I. So this is 8 volts divided by 0.050 amps. And if you calculate, the result is 160 ohms. Next question. R and Z are connected in series to a cell of EMF, 12 volts, and negligible internal resistance. Determine, using the graph, the power dissipated in LAN Z. Right, so we will find the power of the power dissipated in LAN C. It means PC, power of C. And the formula is I, electricity current, times potential difference on Z, on this lamp. Right, so according to information that the electricity current just now we calculate is 0.05 amps, 0.050 times the potential difference is 4. 0.04. And if you calculate, the result is 0.2 watts. No. Number five, the binding energy of the stable nuclide of xenon 131 is 1.105 giga electron volt. Outline what is meant by binding energy. This is my answer, my explanation. Calculate in giga electron volt over C power 2, C squared, the mass of nucleus of xenon 131. Okay, so I will use the rule that binding energy equal mass of separate nucleons minus mass of nucleus. Right? Binding energy, according to this information, is 1.105 giga electron volt. But later I will using this, I will convert into mega electron volt, and mass of separate nucleons is 54 times 938. 54 is number of protons in xenon 131, while 938 is mass of a proton. Yeah. The unit is mega electron volt C power minus 2. Next, plus 77 times 940. Okay. 77 is number of neutrons in xenon 131. Meanwhile, 940 is mass of neutrons, and unit is mega electron volt, centimeters power minus 2. And mass of nucleus is mc, okay, mc squared. So I would like to rearrange this equation becomes mc squared. Mc squared equal, if you calculate this, is 50,652 plus 70,380 minus this is 1.105 giga electron volt, but I will change becomes 1,105 mega electron volt. Right. So M equal 121,927 mega electron volt over C squared. Or this is 121.927 giga electron volt C power minus 2. Or we can round off 122 giga electron volt C power minus 2. Xenon 133 and xenon 131 are two isotopes of xenon. Outline what is meant by isotopes. I have provided my answer this one. Xenon 133 is radioactive, suggests how the binding energy per nucleon for xenon 131 compares with that of xenon 133. Is my answer. Okay. Xenon 133 is radioactive, meaning it undergoes decay to reach a more stable state. This lower stability indicates a lower binding energy per nucleon, while the xenon 131 is stable, meaning its nucleus is tightly bound and more stable. The stability corresponds to a higher binding energy per nucleon. That's my additional information about that question. Determine the number of up quarks, U quarks, in the nucleus of xenon 131. Up quarks or U quarks from protons 2 times 54, 108, while for neutrons 1 times 77 equal 77. 77 because 131 minus 54 equal 77. But the total up quarks, total U quarks is 108 plus 77 equal 100, 185. The graph shows the variation with time of the activity of a pure sample of xenon 133. Estimate the half-life of xenon 133. To estimate the half-life, we need the formula that AT equal A0 times e power minus lambda t. So we can rearrange this formula with lambda becomes the subject, but I would like to write e power minus lambda t equal a t divided by a0. So minus lambda t ln e equal ln at over a0. So ln e equal 1. So it means lambda equal minus 1 over t. Ln at is a 2.5, 9 times 10 power 7. 1. So lambda equal minus 1 over 2.5, okay, times ln a 2.5, this 2.5, because this is when 2.5, okay, so a 2.5 is 6.5. Yeah. It's 2.5 here, and this 2.5. This one, this is 2.5 and 6.5. This is going to be 6.5 here over 6.5 times 10 power 7, 9 times 10 power to the power 7. So it becomes lambda equal minus 1 over 2.5 ln 6.5 over 9. And if you calculate the result, it's 1 divided by 2.5 and 0.325. And if you calculate, the result is 0.130168 on. So we can calculate the half-life T 1/2 equal learn 2 divided by lambda. Lambda is this one, it's a number. So it's going to be learn 2 divided by 0.130168. And the result is 5.324 days, or it is 5.3 days. That's the result. Describe the energy transfer taking place in a wind generator. This is my explanation. One. Next. The maximum power that can be extracted from a wind generator is given by this equation. State one assumption made if in deriving this equation. My explanation is one. The following data are available for a wind generator. These are the data. Determine the maximum power stating the correct unit produced by this wind generator. So we are going to find the swept area first. The swept area, pi times r squared. This is pi times 2.5 squared, because r, according to information, this is 2.5, and it is 6.25 pi. And we use the power equation for wind turbines. The formula is P equal 1/2 rho A times V1 cube minus V2 cube. And it is 1/2 times 1.2, area is 6.25 pi, times 6.8 cube minus 2.6 cube, according to this information. And if you calculate, the result is 3,495.86 watts. Round off becomes 3,500 watts.